What up, Hyperchange? Welcome to another episode. Today we're talking about Tesla's Model Y. This is the upcoming crossover SUV that is set to come out late 2020, built on a similar platform as the Model 3. This is going to address the largest segment of the automotive market, the CUV crossover utility segment. So this has potential to be Tesla's best-selling vehicle and a huge moneymaker for the company. And in this episode, I want to do a deep dive on a couple tweaks Tesla's doing to the manufacturing process. So a little bit nerding out here on some behind-the-scenes stuff, but from an automotive manufacturing process standpoint, there's a couple things that Tesla's patented recently that are going to make the Model Y a huge breakthrough. The idea for this episode came from Sean Mitchell's interview with Sandy Munro, the same inspiration as my Super Bottle episode. So Sean Mitchell asked Sandy Munro, what electric vehicle out of all of them are you most excited to get your hands on and tear apart? And he says, he almost cuts off Sean Mitchell right away and says the Model Y.
Sandy, what pending electric vehicle are you most excited to get your hands on? The Model Y. Mm-hmm. So that's going to be one of the first things that you do next year is try and buy a Model Y.
We have located two guys that claim they can get us a very early model, so that's expensive. You pay through the nose when you if you're not a Tesla insider. Mm-hmm. So we'll get that. We'll start tearing it down. There's many reasons. I want to see what the body looks like, if they've learned any lessons or maybe hired somebody that knew what they were doing. Mm-hmm. That's one thing. The main thing, though, was the wiring. Both of us here are very interested. How do you go from over a kilometer of wire down to 100 meters? 100 meters. Yeah. Right. That's a big deal.
So you're very curious to learn more about what they did there.
I'm pretty sure I know what they did. I mean, you get the same technology inside of a fighter jet and things like that. But the automotive industry has been very, very reluctant to move in that direction. It's cheap to buy an off-the-shelf solenoid, and you pull a bunch of wires to it. Okay, it's heavy, and they're expensive, and the guys on the factory floor don't like them, but they are cheap, and that's kind of the direction. This is not going to be cheap.
And so what makes the Model Y so interesting? The first thing that Sandy Munro cites, sort of a game changer from the automotive, electrical engineering perspective, is the wiring architecture. And this is something that Elon Musk originally mentioned on the Q1 2017 Tesla earnings call. The wiring harness on Model S is about 3 kilometers in length, he said. The wire harness on Model 3 is 1.5 kilometers in length. The wiring harness on Model Y will be 100 meters, and that's a redundant wiring harness. So this sort of caught everybody off guard because obviously going from 3 kilometers down to 1.5 in the Model 3 is a huge improvement, and then down to just 100 meters in the Model S, like a 15-fold reduction in the amount of wiring needed for the car, is sort of a huge breakthrough in that aspect of the vehicle. So this was left to the table, but the other thing that's sort of a wrench in this entire plan is that Elon Musk did say the Model Y would be built on a totally new architecture of the Model 3 at this time, and then had since in later conference calls went back on that and said we're actually scrapping that plan, and we're going to build the Model Y more similarly to the Model 3. But then, just a couple weeks ago, Electrek uncovers this patent from Tesla that basically looks like details this revolutionary wiring harness that Elon Musk mentioned. So now I'm left wondering, scratching my head, is this going to be integrated into Model Y right off the bat, or will it take more time? But anyway, that's another note. But the exciting thing is now we have a lot more details and new info about this wiring harness. So to give you guys a little context on why wiring matters, why is this actually important? I mean, the first thing is less wires means less weight. Less weight in the vehicle means longer range. So that could be a huge deal for cars with electric vehicles where it's all about reducing the weight of the car. But that's only one very small level of this wiring disruption. The other thing is integrating a more cohesive, vertically integrated electronic sort of wiring system approach. Now, if you take a look at this slide from Munro and Associates, you'll see how just like the cooling system that I made a whole episode about, the Tesla Model 3 has a very more integrated wiring system than its competition, the Chevy Bolt, integrated design versus separate standalone components, and they do a great job sort of detailing this in the this diagram. And it is important to note, I think, that as cars get more electric and as we get more autonomous, the need for more wiring is increasing dramatically going forward as cars become essentially computers on wheels. And so that's where Tesla's innovation is so exciting, because I'm going to go right to the patent and read it for you. And it says, description of related art. Traditional car wiring for vehicles are piecemeal solutions. Typically, there are different wiring harnesses that connect different electrical components to a central battery or power power source. Each component receives power, but requires multiple wiring harnesses for communication and signals. The total length of the wire may be many miles on a single vehicle. Those wiring harnesses typically consist of multiple round conductors that are not rigid. Round conductors are not optimal for transmitting current, and the lack of rigidity of traditional wiring harnesses requires assembly into the vehicle using human hands, which can be a slow process. Further, connecting each component to the central battery is not optimized on an automobile level. Hence, there is a need for wires and a wiring system architecture that overcomes the aforementioned drawbacks. And that is exactly what this is that Tesla has designed, this crazy sort of all-in-one, super streamlined, super simplified wiring architecture. And what they say that's so important is, remember what happened with Tesla during the Model 3 ramp. There was a huge struggle with over-automation. They were over-automating everything and needed to hire a ton of people to do manual tasks. Well, that's basically what they're hinting at here, is that this new wiring architecture lends itself way better to automation. There's way less humans involved and required. So then, it appears as if there's a related patent that I wanted to bring up, which is here, that Electric also did an amazing article about, and this basically shows a new type of rigid cable that Tesla has designed for this new wiring architecture. And so they describe it in the patent. Traditional cables, such as component cables, USB cables, or HDMI cables, are easy to manipulate with human hands for connecting with appropriate connectors that are disposed on different structures or devices. However, the installation of these cables is difficult to automate. The cables lack sufficient structural integrity and rigidity to be easily picked up, moved, and placed by a robotic arm. Further, because traditional cables are not rigid, they may not be easily formed in different shapes and routed to predetermined location amidst tight spatial constraints. Routing traditional flexible cables during manufacturing, for example, to connect different components during automobile manufacturing, typically cannot be automated and therefore require humans to place by hand. Such manual placement is time-consuming, tedious, and costly. In addition, while certain traditional cables, like USB Type-C cables, are designed to serve multiple purposes, such as power transmission and video over a single cable, specific applications may not require the transfer of all three types of information. Hence, there is a need for a structural cable that overcomes the aforementioned drawbacks, and that is exactly what Tesla's designed, this sort of thicker, revamped architecture to hold cables that can be much easily placed in a much tighter space by a robotic arm. And so, tying this all together, what is really going on is Tesla's developed a way to do an entirely new wiring architecture that's much simpler, much lighter, reducing it from 1.5 kilometers to 100 meters, which was actually 3 kilometers in the Model S, so a huge reduction in the amount of wiring. But the perhaps even bigger breakthrough that we have going on for Tesla is that they made the installation process be able to do by robots and not humans. This is going to make it, way more reliable, way faster, and potentially way cheaper. And this is why Tesla's vertically integrated approach is so fascinating, and examples like this are a super nerdy deep dive, but are actually a microcosm for the entire disruption that we're seeing occur right now in the automotive industry. Tesla, their vertically integrated approach, they're the only company building their entire car in-house. Every other car company is outsourcing everything to a million different suppliers. That makes it so hard to have a cohesive ground-up design. That's why they have, piecemeal systems for wiring instead of one wiring system, and that's why they're so slow to innovate. And so Tesla, on the other hand, with every single car they design, is rapidly innovating on not only the vehicle design, but the actual manufacturing process. And this is huge because it's about the machine that makes the machine. That's what Elon Musk said. And Tesla's making huge improvements to the machine that makes the machine that are going to directly impact profitability of the company and, CAPEX spent to get vehicles off the ground. So if you look at, reading between the lines on conference calls and the shareholder letters, you can see that Tesla has this laser focus on reducing the amount of CAPEX needed to build vehicles and build out manufacturing lines. And this is exactly a key example of how they're doing that. They've created an entirely new wiring system that seems to work better, that's lighter, but also is going to be much easier to manufacture with robots. So this is literally how Tesla is pushing the cutting edge of automotive manufacturing, integrating robots, and really exciting, fascinating push here. And that is just one little example. But I have another example that researching this sort of led me to find, which is this sort of die stamping and casting patent, which is an entirely new way to assemble the actual shell of the car. So, switching gears a little bit, the wiring harness, as fascinating as that is, this is potentially an even more exciting, evolution of Tesla's manufacturing process, which is, Tesla takes in all these raw materials and then has these huge stamping machines that I've seen in the factory. They're like super loud. It's like kind of scary to see these robots just like stamping like a huge part, 3 or 4 times, this metal that then turns into a door. And so you basically have the system of, you have raw metal going into doors, and then they have all these different parts, and they assemble the parts, and that's what becomes the body in white, which then becomes the actual car once they fill it with all the other stuff. But that's a long way of explaining the build up to this new breakthrough, which Tesla's patented, which at its core is basically just one huge machine to assemble everything at once. It's like, the pictures of it are just insane. It's this, and I think this might actually be related to either the Perbix acquisition or the Groman Engineering acquisition that Tesla had made. One of those sort of heavy manufacturing R&D companies may have actually led to this. So on one hand, we have this patent of this crazy new stamping machine. On the other hand, Elon Musk, a couple months ago, just went on the Ride the Lightning podcast with Ryan McCaffrey, which is an amazing podcast you should check out if you're a Tesla fan. But he basically goes on to describe how the Model Y, he goes into detail about how they're building it, and there's going to be this new process that instead of stamping 70 parts, they're going to have this huge stamping machine that turns it into just 4 parts. And then when they get the big stamping machine, it'll be just 1 part. They're going to take 70 parts and turn them into 1 part. And that means, a much faster, process, a much simpler process, aka less CAPEX. So I think this is really, really interesting when you take a step back, that the Model Y, yes, it's just like the Model 3, but a little bit bigger. It's addressing the CUV segment. I think it could drive huge sales and revenue from the company. But on the back end, Tesla is making these huge innovations in vehicle production that are going to make it way simpler, way more advanced, and also way cheaper to build out the CAPEX. So this is why Tesla is unlike any other automaker, because they're actually, innovating so quickly on these manufacturing technologies that the required CAPEX spend for future vehicle programs is dropping dramatically. This is why Wall Street has such a hard time modeling and understanding this company, because, they everything's too much in a box. It's the stagnation fallacy. Okay, it cost Tesla, $2 billion to get the Model 3 line up and running. It's going to cost them $2 billion to get the Model Y line up and running and take them as long. No, that's not the case. They're learning, they're innovating, they're putting in these new technologies. I mean, a side note on the wiring architecture, think about where the car is going. It's becoming a computer on wheels, and we're just scratching the surface on that. What about when we have self-driving cars and they're driving themselves, and you have to make millions of calculations per second feeding back to this main computer? I mean, the wiring architecture is so critical to the future of an autonomous vehicle that it makes me think like innovations like this may be necessary if you actually want to build an L5 car. Also, I just threw out this poll on Twitter just to see what you guys think, because Elon Musk comments that there is this new revolutionary wiring harness in the Model Y, but is it going to go into the Model Y right away? That's what I'm not sure about. And so I put out a poll on Twitter and asked you guys, and just in like an hour, less than an hour actually, already got 376 replies. 75% of you said yes, this will go in right away. So we'll see what happens. I really wanted to open this video up to feedback from you guys mainly. That's actually the main reason I'm making this video, is sort of to do a collaborative, research process, because I think this new wiring architecture thing is fascinating. I think the stamping machine is super fascinating. If you guys have guesses of, or more analysis about what this could mean for CAPEX, or what this could do for Tesla, or any sort of other, micro manufacturing projects that Tesla's working on like this, please let me know. In my last video about the super bottle, there was so many amazing comments, and you guys corrected me on me saying it was air flowing through the tubes instead of coolant. Huge shout out to thank you for correcting me. Like, I'm trying to do as best as I can and learn everything and get you guys up to speed, but I'm always making errors. Like, I'm just doing my best. I'm like a one-man team researching all of this. So I really, really appreciate all of your feedback and ideas and corrections. It helps me so much. So huge shout out to everybody commenting and sharing their ideas. Anyway, this is Hyperchange. Thank you so much for tuning in. Gotta show some love to our Patreon supporters funding the channel. Thank you so much. I'll see you guys next time. Peace.